Hi, I'm Sandata, yet Villarreal Jr. Welcome to Video Assisted Instruction Data Warehousing Series. And our topic for today, first, the data warehousing system processes. Second, process flow in data warehouse. And the last, when to initiate extract. Let's proceed. System processes. We have a fixed number of operations to be applied on the operational databases. And when we have well-defined technique, such as use normalized data suitable for delivering a keep table small, etc., these techniques are solution. But in case of decision support system, we do not know what query and operation needs to be executed in the future. Therefore, techniques applied on operational database are not suitable for data warehouses. Now, if you're going to ask me about the first paragraph we have here, they mention of what do you call normalized data. So normalization should be in a level, first level or first normal forms, second normal form, and the last we have third normal form. Now this normal form or three normal forms is being used already in the databases, okay, on how to make the data accurate, and that is one of the technique in creating a database system. Now, but right here in delivering a keep table small, of course there are small tables we can create because of its field and because of the emphasis of each data, and it depends upon the business itself. Now there are also tables that are not considered to be making small in terms of the fields, and I think we can use the query to make the table a large table to make them a small table, and that is another technique. So we have two techniques here, using normalized data, and the second is the use of query to make the table small. Now it also mentioned about the decision support system. Now decision support system is one of the methodology of system analysis and design. This decision support system is that what you are going to do is supported by the owner of the business. That's why it is called decision support system. So for example, I am the CEO, and then one of my IT discusses about their system prototype, or they want to create that kind of system. Then the decision must be made by all of the personalities inside of the business, and one personality that can give the decision to go on is the CEO or the owner of the business. That's why it is called decision support system. And this decision support system, they're all similar, but they have different techniques in terms of creating the software or the system itself, because there are methodology that they don't need the CEO, but they can create the system itself. That is the answer with our second paragraph in this slide. Now, third, we have therefore techniques applied on operational databases are not suitable for data warehouses. Of course, they are not suitable. And the technique itself is not exactly on the data warehouses because we are talking about here operational databases. And we mentioned already before that data warehouses are not operational database. So that is what you call our system process. It talks about here the system, but not the data warehouses. Now, second slide we have here. In this topic, we will discuss how to build data warehousing solutions on top open system technologies like Unix and relational databases. This figure number 16 shows Unix system process. By the way, I'm going to discuss first the topic itself because it talks about Unix. Okay, they gave this figure about Unix. So let's have a recap for this. Now, Unix is one of the operating system that has been created and used in the world. Okay, it is Unix is similar to Microsoft. Okay, they are producing system, so like Windows 95. So in Unix we have Ubuntu, Fedora Core, SUSE. So there are plenty, and the best thing here is that it is considered to be GPU. Okay, there are system created by Unix. It is considered to be GPU. GPU stands for General Public License. It means to say you are not going to pay for your software. That is the idea. If you're going to use Windows, you're going to pay for it. So that is one point of I think solution. It mentioned it right here, and they called it a top open system technology. Now let's check out the figure. So right here there is a what you call new. Okay, so new, and the direction is we needed to admit this new, then it will be put up in a ready state. Now on the ready state, you will notice that it will go to the running state, and on the running state, just in case there is a what you call incompleteness of the data, or it is not been yet to be transact, then it will go to terminated or exit. But if there is an error we encountered, or lack of data of the new admitted, then it will go to interrupt. If you are asking about what is interrupt, interrupt is something like in computer, it will look at available part in the system so that the new admitted will be put up on the record, and that is what you call interrupt. There is also a what you call interrupt request. They're going to request to add the new admitted record, okay, to make it available. So that's why we have here, after, let's go back again, new admit, then ready, then run, then if it is finished, it will go to exit. Now, there's a what you call interrupt if there is a problem with the data, and that is what you call interruption. Now, just in case if it is running, it go also right here below. It is a what you call input, output, or event wait. Now, input, output, or event wait is something like you need to wait to save the records. Okay, it could be input. Why? Because you are typing on the field. And it could be output also, because after you type the field, it can be printed also. That's why it can be an output. Now, on the printed area, it could be classified as used by the printer or used by the monitor, because monitor is one of the output also. Okay, there's a what you call right here, after waiting, input, output, or event completion. It means to say that the data has been saved already. So after has been saved, it will go back to ready state, and it will go to the running again. And this what you call the schedule dispatcher. The data will wait, but if you're going to look for it, the schedule dispatcher will run it, the code, then it will display. So the whole system right now is already complete. And again, this is what we call the system, like Windows 10, Windows 7, Windows 8. In Unix, we have Ubuntu, Fedora Core, SUSE. There are plenty, and that is what this talks about. Next. So we are finished now with the data warehousing system processes. When we talk about the system, that is the operating system. Next topic we have is the process flow in data warehouse. Now, process flow in data warehouse, there are 4 major processes that contribute to a data warehouse as follows. First, extract and load the data. Second, cleaning and transforming the data. Third, backup and archive the data. And 4, managing queries and directing them to the appropriate data sources. So we have 4 processes. Okay, this is considered to be major: extract, clean, backup, and manage. Now, we have here in figure 17, this figure show process flow data warehouse. So we have here data source in Spain, data source in London, data source in New York, and data source in Bangalore. Now, the data processing is considered to be right here. Okay, so you will notice that the process of the data, they clean it, they integrate it, they transform it, they load it, and they refresh it. Okay, so that is the process. Now, it will unify on the data warehouse. So after unification, there's a what you call query and analysis tool. So if you're going to ask me, through OLAP, they are connected to each other, and it was been saved to a server named data warehouse. So this is considered to be a server, and this server is considered to be a database. Okay, so this database we mentioned is a data warehouse. Why? Because all of the data of different country right here are saved already in one database, and that is unification.